The first part is graphical graduation, which is the first is handling age range. For wide age range, split data into the groups and plot separately. Use logarithmic scales for better visualization. And dealing with the sparse data, which is group data to ensure each group has a sufficient events. Example, combining data until that's at C5. Also, plotting group rates. Plot group mortality rate at either the median age of the group or the weighted average age. Then we calculate 95% confidence limits. We can use the first equation or the second equation. And if we are dealing with the force of mortality, of course we are graduating logit, then we must use the appropriate standard error. And with drawing the curve, drawing smooth curve passing through roughly 95% of the predictable ensures smoothness while maintaining adherence to data, like this figure. And tabulating values, measure values from the graph, through accuracy is limited. Example, two significant figures. The next one is setting smoothness, which is the difference between rates on the second difference and the difference calculated to assess the curve smoothness. Large or regular difference indicate needing adjustment. This process called hand polishing. Define the curve. On the next one, efficacy test, with statistical tests such as power of 2 are applied to evaluate the goodness of fit. Adjustment to degree of freedom are made to account for certain nature of the method, like reduce the number of degree of freedom. For example, reduce 1 for the height, reduce 1 for the slope, and reduce 1 for curvature.
Okay, for the next part, which is the weighted least square, where weighted least square is used to minimize the weighted sum of squared deviations. So you can choose either to use the left side formula or the right side formula. And as you can see, the snippet image below here in the slide is actually referring to definitions of each of the variables in the formula. Okay, continuing to the weight, which is Wx. It is used to emphasize observation with a higher confidence, which is more reliable data. And you can choose either to use a simple choice or a better choice. For the first one, for simple choice, the weight or Wx can be proportional to the exposure of risk or exposure to risk, which is denoted by Ex. And for a better choice, the weight can be set as Wx equal to Ex over Qxs, or the reciprocal of the variance. For an example, Ex over Qxs times with 1 minus Qxs. And then for the solutions, the straightforward relationship exists for solving A and B. And this can often be done by using a software like Minitab or SPSS. And for the next step, which is after graduations, for the fitting model, after estimating the parameters and fitting the data, you should perform statistical tests to ensure the model is actually adheres to the data or not. And the smoothness of the result model should naturally follow from the method that you are using. For the next part, covering the advantage and disadvantage of the standard table graduations. And for the advantage, the standard table graduations is using information in a more extensive graduations of similar data, where it is eligible for little data. And the standard table is actually showing a smooth progressions, will also resulting in a graduate rates, which is also smooth, and it is incorporate prior expectations of the form of the curve. And the standard table graduations helpful where it have a little data in our new experience of extreme ages. While for the disadvantage, it has a problem in choosing standard table, and it is also have a problem with adherence of the data. The features in the standard table will be exhibited in the graduate rates, and it is not appropriate for producing new standard table, especially for large data. Okay, for the next subtopic, which is 7.3, graduation by mathematical formula. This graduation by mathematical formula is preferred method for the larger data sets, where it is related other than graduation methods, including use of the spline functions. And this graduation by mathematical formula has a difficulty with choosing the pivotal edges, which is known as knots, but can be easily done with computing facilities.
Three parametric formula in graduation. The first one is Goldberg, which is mu x is equal to b c power of x. Second one is Maclaurin, which is mu x is equal to a plus b c power of x. And third is Peirce, which is mu x is equal to a plus b c power of x over b c power of negative x plus 1 plus b c power of x. Next, the table 8.9 stroke 52 was graduated using Qx is equal to a plus bc power of x over ec power of negative 2x plus 1 plus bc power of x. And the table A67 of stroke 70 was graduated using Qx over px is equal to a plus hx plus bc power of x. The mathematical formula used by continuous mortality investigation, typically in linear or quadratic usage, which is logit Qx is equal to B0 plus B1x plus B2x power of 2. And this transform function, logit Qx, is easier to model than Qx. Problem for single formula problem is the capturing all the features of a typical mortality experience. Which is, this formula is from Australian National 1960 through 62 graduation formula, which is term 1 is the infant mortality, term 2 is the harm, and term 3 is general aging. First McCahon family, which is let R and S be integers higher and equal, which are not both 0 and let A stroke is equal to A1, A2, A, R plus S. So the vector of parameter definition, it will be like this, where GM is referred to Gompers McCahon.
So Assalamualaikum. Hi, and my name is Ashraf. So I'm going to present about the graphical graduation method. So in this method, basically it is a smooth curve fitting to data by hand, and it always used mainly for small data sets. And this method balances smoothness and data adherence. So next we go to the step of the method, which is the first of this method will be age range grouping, such as with age will be split range, which is above 60 or lower than 60, and then the log QS will be plot or log QX over 1 minus QX, and then for the next step will be grouping sparse data, which is in this phase the data will be combined until death exceed than 5, then it will be plot. So which is in the next step will be crude rates will be plotting, which is in this step mid or weighted average age will be plot. So and then after that will be confidence limits, which is in this step 95% of limits will be calculated, which is Q plus minus with 2 square root with D over E. And then after that the curve will be drawing, which is in this step curve through 95% confidence interval will be smooth. And then will be tabulation, which is in this step it will be the values will be extract from the graph, which is this part will be challenging for high accuracy. And then the next step will be smoothest check, which is in this step will be analyzed for smooth progression, and it will be used hand polishing if it is needed. And then lastly will be adequate testing, which is the test will be applied to adjust for degrees of freedom.
Next is the Gompers formula, which is GM02 alpha x, and Markov formula, which is GM12 alpha x. You can see that QS over PS equal to GMRS alpha s, which is QS equal to GMRS alpha s over 1 plus GMRS alpha s. We have the log QS over PS equal to polynomial in S degree of n, which is QS GM 0n alpha s over 1 plus GM 0n alpha s. And lastly, the logic complex Markov formula of type LS is then defined as LGM LS alpha s equal to GM LS alpha s over 1 plus GM alpha s. Next is the basic process which has to be followed. Which firstly is to choose which member of the GM or LGM family to use and fix R and S. This is done by examining the shape of various probably low order GM or LGM formula. Next is to determine the parameter alpha, which is best fit for the data. There are three main methods to use, which is weighted least square. Next is the minimum S square or maximum likelihood. Third, in practice, there are several models that may be fitted for the aim of being able to find the model that is relatively few parameters with adequate shape and data adherence. Next is the advantages of parametric graduation. Firstly, the smoothness is guaranteed by providing a reasonably low order formula and is suitable for large datasets. It is, however, not subjective, and with computer appropriate estimation, we can assess the significance of the improvement in the model fit as additional parameters. If the same formula is fitted to different experiences, the parameter estimates can be compared possibly with intuitive interpretation. And lastly is the disadvantages of parametric graduation. Firstly, it is often difficult to fit a single curve to the entire range, which is adequate for the model's infantry mortality or accident harm or normal aging. It is usually difficult to deal with small datasets. In particular, extrapolation of value can be unreliable when formula are being used. And lastly, is the usual problem is if there are heterogeneous data to analyze. And that is all from us. Thank you.